Okay, here we're talking about the difference quotient. You're going to use it right now, and you're also going to use it in one of your later chapters when we start talking about derivatives. So the difference quotient, I break it up into 3 steps. My first step, I say, is to find f of x plus h. That is the hardest step for sure. My function up here is x squared minus 3x plus 7. Anytime you're evaluating a function, you put what's in parentheses where x was. So that means we're going to put x plus h right here. And truthfully, and here of course, truthfully that's the hardest part of the whole problem. So what you're going to get is x plus h squared minus 3 times x plus h plus 7. Now, I have to square out x plus h. That means write it twice in FOIL. Now, in all difference quotients with a square, this is how this step's going to look. It's going to be the same every time. Sorry, got a little messy there. So we're going to have x squared plus 2xh plus h squared minus 3x minus 3h plus 7. Okay, and that's the end of step 1. That's how that little part would look. Now step 2 says you take f of x plus h, this is the difference, and you take f of x. So how that plays out with us is that this piece right here is the end of step 1, and this piece right here is the original. So we get x squared plus 2xh plus h squared minus 3x minus 3h plus 7. Okay, that's the end of step 1. And the original is the original function, x squared minus 3x plus 7. Okay, so you take the end of step 1 and subtract the original from it. X squared subtracts out, 3x subtracts out, and 7 subtracts out. So that brings us to step 3. What we have left is 2xh plus h squared minus 3h. That's what remains. So your last step is to divide by h. You're going to divide each and every term by h. And what you get out of that is 2x plus h minus 3. Okay, there's your first one. Okay, so let's try another one. We start out with saying f of x plus h. So we get 2x squared plus 5x minus 1. Remember that x plus h is what goes in the missing places. Now then, I'm going to square out x plus h. Remember I did it earlier, so I don't want to really do it twice. So if you square out x plus h, you can look earlier, and you get x squared plus 2xh plus h squared. Okay, and that's what you get when you square out that binomial. You can distribute through and get 5x plus 5h minus 1. Okay, my pen's doing a little funny business, so let me see if I can clean it up just a little bit. Now, let me double check it. Okay, I think it looks right now. Let me go ahead and distribute the 2. So we get 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 1. And that's the end of step 1. So step 2 is to take all that whole big value, 2x squared plus 4xh. The whole thing. And from that, you're going to subtract the beginning function, 2x squared plus 5x minus 1. Okay, and that's going to be step 2. So we'll see what subtracts out. A 2x squared subtracts out, a 5x subtracts out, and a 1 subtracts out. So that leaves me with a 4xh plus 2h squared plus 5h. That's step 2. Step 3 is to divide by h. So I get 4x plus 2h plus 5. And that's my answer. The last concept here is a piecewise function, and we're going to use this in great detail in our limit section. But right now, just showing you what a piecewise function looks like. It has two sides, a top side and a bottom side. Now remember, when we evaluate a function, this little value here, the 6, that's x. So you'll see I'm going to use the top function if x is more than 2, and I'm going to use the bottom function if x is less than 2. Since 6 is more than 2, tell you what, let me write it a different way. Since 6 is greater than 2, we're going to use the top function. So we're going to say 1/2 of 6 plus 1. Okay, and that's all that we'll do. We'll simplify it out. 1/2 of 6 would be 3. 3 plus 1 is 4. And that's your answer, and that's how you evaluate a piecewise function. The second one is 0. What I notice about 0 is less than 2, so that means we're going to use the bottom function. 2 times 0 minus 1. So 0 minus 1 is a negative 1. Lastly, I have f of negative 1. Negative 1 is less than 2, so that tells me I'm going to use the bottom function. So 2 times negative 1 minus 1. That would be negative 2 minus 1, which would be negative 3. Now you'll say, well, what happens at 2? Well, when you get to 2, when I've asked you to evaluate f of 2, that's where our limits come in, and you'll see that in our next chapter.